So in this video, I'm going to explain to you how earthquakes affect the surface of the earth. So you want to get your notes K in your notebook. And I always say you should have your notes open on one window and then have this video open in the other window so that you can easily go back and forth. Otherwise, it makes it difficult. So we know that earthquakes are caused by the movement of the crust, but that movement builds up over a period of hundreds or even thousands of years. So what happens is, this is the crust right here. There are places where the earth has snapped before. So we call that a fault. A fault is like a boundary, but there's lots of little faults around plate boundaries. It's places where the earth kind of cracks. All right? So if there's no pressure, no movement, that's called an unstrained crust, or nothing going on there. But over a period of time, there might be some movement. You know, this crust is just getting pushed a little bit. Nothing's going to move dramatically, but over a period of time, it might start bending the crust. This crust is under great strain, and so we say there's strain at the fault. There's pressure that's building up. There's still no earthquake, but there's a lot of pressure that's building. At some point, right? So if you take your two hands and you push them together really hard, and then you try to slide them by each other, it doesn't work. At some point, it just jolts like that because the pressure, the friction that was stopping the movement was overcome by the pressure buildup. And so what happens, in this picture, we have more and more pressure building up. When it's greater than friction, that piece just snaps and you have that movement. And that's the earthquake. So maybe that pressure's been building up for 100 years and then finally something snaps. And so that sudden movement, that release of pressure is an earthquake. Sometimes that happens, in North Carolina. We're not even on a plate boundary, but it kind of buckles, in the middle. So where you have faults, you have different kinds of faults depending on the kind of movement of the crust. So if the crust is moving away from each other, like here, we call that what kind of boundary? That's right, it's a divergent boundary, right? We call that a normal fault. I don't know why they call that normal, but that's what they call it. A normal fault, and you can see that this is kind of it's like a cliff, but it's not straight up and down, all right? So that's going to happen, at divergent boundaries, where the faults are divergent anyway. This one, look what's happened here. They're not moving away from each other, and they're not moving towards each other, they're just sliding by one another, We haven't even talked about that kind of boundary. That's called a transform boundary. But the fault you call a strike-slip fault, and that happens at transform boundaries. Those are not convergent, they're not divergent, they're just sliding by one another. So, no mountains are made, no volcanoes are made, there's no subduction or anything, so they're kind of boring, but there's a lot of those. So if you see things like rivers or fences that are sort of, pushed to the side like this, that's called strike-slip. And then we have the opposite of divergent would be convergent. And so you call this a reverse fault. Like I said, I don't know why they name them this way. It's the reverse of a normal fault. And you can see here it's more than 90 degrees. It's not even straight up and down. It's more than straight up and down as opposed to this one. And so that happens at convergent boundaries where the plates, where crust is moving towards itself. So those are the three kinds of faults. Normal looks like this, strike slip looks like this, and reverse looks like that. Whoa, we skipped ahead. Oh, no, we didn't. So now we get to explain tsunamis. And so if you look here, I know these are kind of crazy looking drawings, but I drew them myself. I'm so proud of myself. But we have subduction going on. So this is one plate moving down underneath another one. So I like to do it like this. So this is what's happening. This plate is moving down underneath this one. But it's not so smooth, okay? I'm going to show you what happens here. Okay, so first this is going to happen over, underneath the water, because a tsunami is a huge wave, right? So what's going to happen, that's the water level, is, and you should do this with your hands. One of these plates is moving down like this, but there's an incredible amount of friction right here. So what happens is it gets stuck, and you can see what happens to that one plate. It kind of bends. This plate here sort of under pressure kind of gets bent. And we're talking about solid rock, right? So we're going to draw that and see how I read that on here. So over time, friction between the plates prevents the movement. One plate bends down, just like that. I know it's not a very good drawing, but we're just showing that plate, this plate right here. Oh no, this plate right here is kind of is bending down, all right? Bending down. So that pressure is going to grow. I mean, imagine you're bending, hundreds of miles of rock. That's a lot of pressure. What's going to happen at some point, right? There's all this pressure building up behind it. Well, that's going to just, when that pressure is more than friction before, it's going to snap back. Imagine that, right? It's going down, and then it's going like this, and then it just snaps back. If that snaps back, what's going to happen to this water above here? That water above there, right? And when that plate springs back, that water above the plate is going to move up, right? It's going to move up just as much. If that plate snapped up 20 feet, now you have a 20-foot wave, 20 feet of water, because you can't compress water. So now that wave is going to move in both directions. And that is a tsunami. And I'm going to show you a picture of a tsunami. So wave travels in both directions, and it travels pretty quickly. So here's a short little movie about a tsunami. Get out of here. So when a tsunami approaches, the water actually recedes. So the water is kind of taken up with that wave. And so if you're ever at the beach and the water goes way back like that, way further than it ever would at a low tide, you know there's a tsunami, and you have to go to high ground pretty quickly. That's no joke. So here comes maybe a 20 or 10 or 20 foot wave. There's nothing more destructive than moving water. Now this video doesn't show it, but all those houses, I'm sure, are gone. And there's going to be more than one wave. Usually there's several of these tsunami waves. And there you have it. So there is what happens, and we're going to do hotspots later.